welcome all of you to third session of your physics paper 1 syllabus. So we have started our unit number 1, which is related with wave and sound. We have seen that a wave is nothing but a propagation of oscillatory disturbance that carries energy from one point to another point without a net movement of particles in that medium. The ripples that will be created on water surface when we throw some stone in water is an example of wave. Even the waves will be generated on guitar strings, sonometer string that you have carried out the experiment of sonometer in your lab also. There are various aspects by which we can classify a wave into different types. The very first aspect is related with the medium required for the propagation of wave. Depending on the medium required for propagation, a wave is classified into two types, that is mechanical wave and electromagnetic wave. Mechanical wave requires some material medium to propagate, whereas electromagnetic wave does not require any material medium to propagate. Thus, it can travel through vacuum also. But a mechanical wave cannot travel through vacuum. The speed of mechanical wave is much slower as compared to the speed of electromagnetic wave. The examples of mechanical wave, we know these are the sound waves or the ripples that has been generated on the water surface. These are the mechanical waves. Whereas light waves, radio waves are the examples of electromagnetic waves. Apart from mechanical waves and electromagnetic waves, there is a third kind of wave, what is known as the matter wave. Matter wave is a concept that is related with the de Broglie's hypothesis. This says that de Broglie's hypothesis says that a wave is always related with a moving body. So, a wave associated with proton, neutron, electron like elementary particles are known as the matter wave. It is treated as a third kind of wave. This is the wave classification depending on the medium required for the propagation. There is another aspect by which we can classify wave into two types. This aspect depends on the direction of vibration of particles. So, depending on the direction of vibration of particles of that material medium, a wave is classified as a longitudinal wave or a transverse wave. In case of longitudinal wave, the vibration of particle takes place in the same direction as that of the direction of propagation of wave. Whereas in case of transverse wave, the vibration of particle takes place in a direction perpendicular to the direction of propagation of wave. So this is the basic difference between a longitudinal wave and a transverse wave. Apart from this basic difference, there are many things that are not common in transverse wave and longitudinal waves, such as in case of transverse wave, there are crests and troughs, whereas in a longitudinal wave, there are compressions and rarefactions. A transverse wave can travel through solid and on the surface of liquids, but it cannot travel through gases, whereas a longitudinal wave can travel through solid, liquid, as well as it can travel through gases also. When we consider a transverse wave, when a transverse wave propagates through a medium, there is no change in the density of that medium. The density of medium doesn't changes when a transverse wave propagates through it. whereas the density of medium changes as a wave propagates through it, then the wave is of longitudinal type. When a longitudinal wave propagates through a medium, there is a change in the density of that medium. The transverse waves can be polarized, whereas longitudinal waves cannot be polarized. The examples of transverse waves are the light waves, the vibrations in a stream, the ripples generated on the water surface, or seismic S waves. These are the examples of transverse waves, whereas the sound waves or the seismic P waves are the examples of longitudinal waves. So these are the classification schemes of a wave. Whenever we say a wave, there are certain parameters we must know about a wave. What are that important parameters? These are nothing but the wavelength denoted by lambda having dimensions of length. It is nothing but the distance between two successive particles of a wave that are in same state. Time period T is nothing but the time taken by a wave to complete one oscillation. This is one oscillation, one twist and one trough. It form one oscillation, and time taken by a wave to complete one oscillation we call it as the time period T. Number of vibrations made by the particle in a medium in 1 second, the number of vibrations, number of ups and downs, compression and reactions made by the particle in 1 second are known as the frequency, and is having unit hertz. Amplitude, denoted by small a, is nothing but the maximum displacement of a particle from its mean position. Amplitude is nothing but the maximum displacement of a particle from its mean position. The speed of a wave is nothing but the distance traveled by a wave in unit time. Thus, we know speed is nothing but distance per unit time. If we consider one oscillation, it will take a time period t and it covers a distance lambda. So speed is equals to lambda by t, but 1 by t is nothing but frequency u. So speed of a wave is nothing but the multiplication of its wavelength and its frequency. This is a formula that we must remember if we have to solve various mathematical problems in exam. So these are the two important parameters associated with a wave. So once we know all these parameters, and yes, there is one more very important parameter associated with the wave, and that is nothing but the phase phi. Phase phi, it can be measured in the unit of distance or time or angle. Usually, angle is used to measure phase pi of a wave. Angle, either in the unit of radian or in the unit of degrees, is measured whenever we have to consider the mathematical expression of a wave. So what is a phase? A phase is nothing but a parameter that describes the change in the alignment, the change in the alignment of two waves having same wavelength and having same frequency. So it describes the change in the alignment of two waves. So whenever we consider a phase, we have to keep in mind that it is not an absolute concept, but it is something which is a relative concept. It is a relative concept. Whenever we consider a phase, it gives a comparison between two waves. So, phase, the two propagating waves could be in phase. We say it as in phase waves whenever crest coincide with crest of another wave, trough coincide with trough of another wave. Whereas the waves, two waves are said to be out of phase when crest of one wave coincide with trough of another wave, trough of one wave coincide with crest of another wave. So such type of waves are said to be out of phase waves. So in between this in phase and out of phase situation, there is certain in between situation where the phase has values in between 0 to pi, not 0 or not pi, but it is having certain value in between these two values. So in that case, if we have to calculate the phase difference between any two points of two waves that are same in frequency and same in wavelength, but have some change in the alignment. So, in order to calculate the phase difference between these two points, we have to use the formula f phi equals to x by lambda, that is the wavelength of wave lambda, x by lambda multiplied by 2 pi. So, whatever answer we will get, that we call it as the phase difference phi between the two points. So this is again an important parameter associated with a wave. If we know all these mathematical parameters associated with the wave, like lambda, frequency, speed, and all these parameters, so we can write down the mathematical expression of a wave. Consider a plane progressive wave traveling along positive x-axis. Then such a wave could be represented in various forms that has been given here. So these various forms are very important whenever you have to solve the numericals in your exam. So there are various ways by which we can write down the mathematical expression of a wave. So next to this, we have to study a very important phenomena associated with a wave. That is nothing but the superposition of waves. Superposition of waves. So many of us, we have used the old radios, and in that old radios, what we try by circulating that knob is that we are trying to match or to get the desired frequency among all frequencies that are available in the nearby medium. So there are many frequencies that are available, out of which we have to capture a particular frequency. So superposition principle is associated with that thing. Superposition principle says that the displacement at any time due to any number of waves meeting simultaneously at a particular point in a medium is the vector sum of individual displacements. It is not an ordinary sum, but it is the vector sum of individual displacements due to each one of the wave at that point at the same time. So it is said that the superposition principle says that the net displacement at any time due to any number of waves meeting simultaneously at a point in the medium is the algebraic sum of individual displacements produced due to each of the wave at that point. is the superposition principle, which is valid only for small disturbances. The superposition principle is valid only for small dis- disturbances. For example, let us consider two waves. One shown by this yellow color. This is one wave propagating along positive x direction. Let us consider another wave shown by this green color, which is again propagating in positive x direction. So if we consider a particular point, say this point, this point, so at this point, at this particular point, as per the superposition of waves, the resultant wave is nothing but the combination of the algebraic sum of these two waves. That is, the resultant wave, the amplitude for resultant wave will be y equals to value of this wave 3 plus 4. That is 7 will be the amplitude of this wave at this particular point. Exactly opposite to this, if we consider this particular situation, wherein crest and trough of two waves are coinciding with one another. In this case, the resultant amplitude of wave is not equal to 3 plus 4, but it is the vector sum, it is a vector addition. So we have to take it as 3 minus 4. This is the resultant amplitude at this position due to the superposition of waves, due to the superposition of these two waves. So this is what the superposition principle is. Now there are three applications of principle of superposition. These are the very important applications. These are nothing but the formation of beats, interference, and stationary waves. So let us see one by one. All these are the applications of superposition principle. All these concepts are related to this superposition principle. So let us first see what is meant by beat and how this beat get formed. So let us see what is meant by a beat. Let us consider two sound waves such that these two sound waves are having slightly different frequencies traveling in a medium along same direction. When these two sound waves get superimposed on each other, what we will observe that the intensity of resultant sound at a particular position rises and falls regularly with time. This phenomena of regular variation in intensity of sound with time at a particular position is called beats. So what you will verify here, suppose you are having two tuning forks. You will vibrate that tuning fork with some rubber and you will get some waves. So what we can do is just down a wax to one of the fork of tuning fork, and these two tuning forks again repeat the same experiment, give some vibrations to that tuning fork such that a wave will be generated. But now, as we have added some wax to one of the tuning forks, what will happen? The frequency of these two waves generated by these two tuning forks will be slightly different. So as a result, when the these two waves get superimposed on each other, what we'll observe? we will get a sound such that its intensity is increasing and decreasing regularly. So such a regular increase and decrease in the intensity of sound wave, we call it as the beat. So when we consider, let us consider two waves with frequency, angular frequency omega 1, omega 2, which is equals to 2 pi f1 and 2 pi f2 respectively, such that there is a slight difference between f1 and f2. So when these two waves get superimposed to each other, what what we will observe? We will observe that there is a repetitive increase and decrease and increase and decrease in the resultant intensity of resultant wave. What we call it as the beat phenomenon. So this maximum up to next maximum followed by one minimum. We call is this much as one beat. It is known as one beat. How we can understand this phenomena of beat using mathematical expressions? So let us consider two waves y1 equals to a sine omega 1 t, that is a sine 2 pi f1 t, y2 a sine 2 pi f2 t. So the resultant wave is given by using the superposition principle. The resultant wave is nothing but y equals to y1 plus y2. Substituting these values, we will get a sine 2 pi f1t plus a sine 2 pi f2 t. By using the sine A plus sine B formula, we will get this expression for resultant wave, and we can write down this expression as y equals to capital A sine pi f1 plus f2 t, where this A, for this much term we have substituted capital A, and is nothing but the amplitude of resultant wave. So we will notice here that the capital A, which is the amplitude of resultant wave, is not constant term, something like 2a or a. It is not a constant term, but is found to be varying with time. What we have observed here, the combination of two waves having slightly different frequencies, it generates the beat pattern such that the amplitude of resultant wave is not constant one, but is again varying with respect to time. It is again forming a wave pattern itself. Apart from this resultant wave, apart from this resultant wave, amplitude of the wave also form a wave, which is given by A equals to 2A cos pi f1 minus f2 t. This is the amplitude of resultant wave. So we can notice here that the expression for this resultant wave is nothing but A sin pi f1 plus f2 t, whereas the pattern, this amplitude pattern followed by this amplitude, is given by 2A cos pi f1 minus f2 t. So this is how a beat can be produced by the combination of two waves that are having slightly different frequencies. There are few terminologies that we must remember whenever we are dealing with a beat. One beat is nothing but a maximum of intensity. It is nothing but when the intensity becomes maximum, again after becoming minimum once in between. The difference between this maxima followed by next maxima and successive maxima, followed by a minima. This will form one beat. The number of beats produced per second is called beat frequency and is given by f1 minus f2. The difference between the two frequencies of basic waves, it is nothing but the beat frequency f. The beat period is nothing but the time interval between two successive beats and is given by 1 upon beat frequency. So these are the few things that we must know about a beat. The next application of principle of superposition is nothing but the interference. We already studied the concept of interference at 12th standard. We have seen that when two waves of same frequency, same wavelength and same velocity having almost same amplitude moves in the same direction, when it gets superimposed with each other, it results into the interference pattern. So what is interference? It is nothing but the modification of intensity due to superposition of two or more waves. It is the modification of intensity due to superposition of two or more waves. We call it as the interference. An interference could be a constructive interference or it could be a destructive interference. In case of constructive interference, the resultant intensity, let us consider two waves, combination of two waves, this red wave and green wave, these are the input waves. Combination of these two waves results into this blue wave. So, when crest of two waves get superimposed to one another, it will increase the resultant intensity. So we call it as the constructive interference. Same is the case when trough of one wave coincide with trough of another wave. Again, this is an example of constructive interference wherein the resultant intensity gets maximum or get increased due to the combination of these two input waves. This is again a case of constructive interference. Whereas when we consider the two waves such that the two waves are out of phase, for example, this red one is one wave and green one is another wave. When these two waves get superimposed on one another, the resultant wave is such that there is decrease in intensity, decrease in amplitude of this resultant wave as compared to the two waves. So such type of interference we call it as the destructive interference. Another phenomenon which is very important from the point of view of your syllabus is the phenomenon of stationary waves. Stationary waves. It is also known as the standing waves. So how stationary waves get formed? When two identical progressive waves in a line, either longitudinal or transversal. So when two identical progressive waves having same wavelength, frequency, period and speed traveling along the same path but exactly in opposite direction. But exactly in opposite direction interfere each other, then the resultant wave that will be formed is known as the stationary wave. It is known as the stationary wave. For example, suppose you are holding a rope in your hand such that the another end of that rope is fixed at some rigid support. So you are holding this rope and you will give some vertical jerk to this rope. So as a result, what will happen? A transverse wave will be generated on that rope. A transverse wave propagates in forward direction and reach up to this rigid support, from which it get reflected back. It get reflected back with the same wavelength, frequency and speed, but with a phase difference of pi. These two waves are having a phase difference of pi. So as a combination of one wave traveling in positive x direction, say this is the positive x direction. So the combination of one wave traveling in positive x direction and a reflected wave traveling in negative x direction, the combination of these two waves, whatever combination we will get, we called it as a standing wave, or we call it as the stationary wave, wherein the particles vibrate at this position, but they will not carry any type of energy in forward or backward wave. Rather, the stationary waves are known for holding the energy at that particular space. So, what is the mathematical treatment of a stationary wave? It is considered a progressive wave. Y1 equals to A sine omega t minus kx. The reflected wave, which is having the same frequency, wavelength, speed as compared to this progressive wave, is represented by y2 equals to a sine omega t plus kx. As wave is propagating in negative x direction, we are using here plus kx term. So the resultant wave is given by y equals to y1 plus y2 equals to a sine omega t minus kx plus a sine omega t, this was minus kx, this is plus kx. So using the formula sin A plus sin B equals to 2 sin A plus B by 2 cos A minus B by 2, we will get the resultant wave equals to y equals to 2a sin omega t cos minus kx. But cos minus theta equals to cos theta. So it is nothing but 2a sin omega t cos kx, or we can write down it as some capital A sin omega t. Rearranging this omega, we will get y equals to a sin 2 pi t by capital T, where capital T is the time period of individual wave. Here is A, capital A is nothing but 2a cos 2 pi x by lambda is the amplitude of resultant wave. It is the amplitude of stationary wave. This amplitude is not something constant term like 2a, but it is found to be a term which is varying. As there is a cos term, we say it is a varying cos term including x. So we say amplitude of stationary wave is not a constant, but it varies with x. So from this mathematical statement, what we have observed? We have observed that the superposition of progressive wave and its reflected wave is again a wave. It is again a wave. Since we are getting a wave equation here, we say that the resultant of these two waves is again a wave having same time period t. But as the sine angle does not contain any x term, as the sine angle is sine 2 pi t by capital T. In this angle term, there is no any x term. So we can say the resultant wave is not a progressive wave. It is not moving forward or backward. That's why such type of wave is known as a stationary wave. As it is not moving forward or backward, it is not carrying energy forward or backward. It is just holding the energy at that particular point. Now here, due to the combination of these two waves, progressive wave and its reflected wave, we will get the maximum of amplitude, minimum of amplitude, maximum of amplitude, minimum of amplitude. We will get successive maxima and minima whenever we consider a stationary wave. So these maxima, where the amplitude become maximum, is known as antinode, whereas the points where is amplitude is minimum or is zero are known as nodes, node displacement, nodes. So the next point is about this node. The amplitude of stationary wave is maximum, that is equals to 2a, then this amplitude term will become maximum when this cos term become 1, and this cos term become 1 when the x will be 0 or lambda by 2 and so on. So these points where the amplitude of stationary wave is maximum are known as the antinodes. Antinodes. And the distance between two successive antinodes is nothing but lambda by 2. It is the lambda by 2. This is some mistake. Like maxima, there are minima also. The amplitude of stationary wave is minimum when the cos angle term is 0. That is, when x is equals to lambda by 4, 3 lambda by 4, 5 lambda by 4, and next points. So these points where the amplitude of stationary wave is minimum are known as the nodes. Thus, the distance between two successive nodes is lambda by 2. Whereas, when we consider a node and its successive antinode, the difference between nodes and that successive antinode will be lambda by 4. So, when we compare a progressive wave with a stationary wave, we will get few points. What are that points? A progressive wave is produced due to a kind of disturbance in a medium, whereas a stationary wave is produced when two identical progressive waves traveling through a medium along same path but in opposite direction interfere with each other. It results in the formation of stationary waves. A progressive wave moves away from the origin, whereas a stationary wave is stationary. It cannot move into the space. As it can't move from one position to another position, it is not transferring any kind of energy. But in case of progressive wave, it is known to carry energy from one place to another place. In case of progressive wave, the particles of medium vibrate with same amplitude, whereas the amplitude doesn't remain constant for stationary waves. In case of progressive waves, a phase changes from particle to particle, whereas in case of stationary waves, a phase does not change from particle to particle, but particles in one group are in same phase, whereas the particles in next group are in opposite phase. That is, phase change occurs from loop to loop. For example, if particles in this one particular loop All particles in this one loop vibrate in same phase. All these particles are in same phase, whereas particles next to this loop are in opposite phase. All particles in this one loop are in same phase, but the phase of this particle is opposite to that of the previous loop. So in this way, a phase changes from loop to loop, and particles in one loop are having the same phase. So in this way, in case of stationary waves, the phase does not change from particle to particle, but it changes from loop to loop. Whereas in case of progressive wave, phase changes from particle to particle. These are the few basic differences between a progressive wave and a stationary wave. In next session, we will see some mathematical treatment on stationary wave on a string and in a pipe. So after that, take care and be safe. Goodbye.